Compensation for acid-base imbalances, right? So we learned that back in chemistry that pH is the measure of the acidity or the alkalinity, whether something is very acidic or very basic, and everything is based off of this pH scale, right? So if you remember, anything less than 7 is acidic, anything greater than 7 is basic or alkalicic, and at the number 7, it is known as neutral, right? And many of these homeostatic imbalances, whether it regards to the pH changes, abnormal pH changes, this can cause a lot of physiological problems, right? So first, we're going to just talk about this pH problem of respiratory. So respiratory acidosis and alkalosis. This is where they coined the term. If I put the pH here, so low pH, high pH. So if we look at acidosis, hypercapnia is usually the main cause of this pH problem. Hypercapnia is the increased concentration of carbon dioxide in your body, right? So carbon dioxide, the way its main form of transport is through carbonic acid. So if you remember from the charts we were talking about, so carbonic acid. So if you have more carbon dioxide, your pH level goes down, all right? So hypercapnia is the main cause of this, right? So this can be either due to hypoventilation, so hypoventilation, so abnormally low breathing rate, or a decrease in permeability of diffusion. So there could be diffusion problems as well. Right? So your body needs to fix this. This is a problem, right? You don't want to have the body's pH to be very low because this can lead to certain kinds of instances of comas and eventually death, right? So your body compensates through this. Respiratory problems, respiratory homeostatic balances involving acidity and basicity is compensated via metabolic processes. So compensated via metabolic processes, right? So how does it do it metabolically? So both of them are metabolically. So I put here metabolic compensation. So how would they compensate metabolically, right? So you need to increase the pH. You want to make it more basic. There are two specific chemicals that regulate this pH metabolically. One is the hydrogen ions, and the other is the bicarbonate. Bicarbonate is a base, the hydrogen ion is an acid. So what your body does in order to compensate respiratory acidosis metabolically is through increase the hydrogen secretion, as in leaving your body, and the increase bicarbonate reabsorption. Right? So this makes sense because if you begin to increase the hydrogen secretion, so you're shooting more hydrogen outside, so the pH goes lower, and you reabsorb more bicarbonate, which is a base. What happens to your acidity or basicity of your body, right? What happens to the pH? The pH goes up. All right? Vice versa, a phenomenon called hypocapnia, right? This is a phenomenon where you have low CO2 concentration, right, in your blood. This can be due to an abnormality in your ventilation rate. So this is called hyperventilation. So you begin to breathe excessively. And this leads to an increased concentration of your oxygen, but also a decreased concentration of your carbon dioxide, which leads to this alkaline phenomena in your respiratory system, right? And then eventually can have effect based off of diffusion. So if the diffusion rate increases, this can lead to other physiological phenomena. So acidosis is regulated via metabolic pathway. The same way is through alkalosis, respiratory alkalosis, through metabolic compensation. So the way the body does it is the opposite of this, right? So here you have an increased bicarbonate, HCO3 minus, secretion, and then you have an increased hydrogen ion reabsorption, right? And all of this is taking place in your kidneys, right? So this is all in your renal system, right? So in your proximal convoluted tubule, in your kidneys, this metabolic compensation takes place in order to fix these homeostatic balances that is regulating with your pH in the respiratory tract.